Dear students, today we will discuss in data communication, the data communication devices, communication media, which is used in order to achieve communication on network and communication network architectures. So before I discuss all these three topics one by one, slide wise, first I want to give you a brief summary about these topics. So here I try to explain you in a very easiest manner in a summarized form that what is actually data communication devices and which type of communication media we are using in order to transfer data from one position from source to destination, and what are the communication network architectures we have. As far as data communication devices are concerned, we have many data communication devices which the help of which we transfer the data from one point to another point from source to destination. So uh, basically, if we are connected our devices within a lane loop which we call local area network, so we are using a LAN card. So LAN card is a network device. Sometimes we also call LAN card as network interface card, that is NIC. What LAN card do actually? It takes the data arrives from the wires, that is communication medium, and when it reaches towards to the LAN card, that is network interface card, it converts that analog data into a uh, it in digital data, or sometimes it is already, as far as local area network is concerned, data is already in uh, digital form. It is not in analog form, because when we have modem device, then we have modem is a device which converts analog data into digital one. So as far as we are discussing about LAN card, so whatever the data traveled from any wired or wireless medium, when it reaches to the local area network, uh, that is in any LAN card, any computer having a LAN card, so with the help of LAN card, it enters into your computer device. That message, whatever the message is sent for the any specific device, so any network interface card basically have an specific IP address and machine address as well. How you can differentiate between machine address and IP address as well? In 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 order to communicate in a network, each and every device has its unique network identity, so that on the basis of that address, communication can be made. So this is called IP address. Then the IP address can vary. Every computer in a network have a unique IP address, but IP address can vary. Sometimes we assign IP address manually, sometimes using uh, uh, automatically using domain name systems, or uh, we have different other mechanisms through which we assign automatic IPs. But there is another unique identity of that particular device LAN card. We call it MAC address, that is machine address. MAC address of all the LAN cards available in this world are different. Every LAN card is having a different MAC address. So this is the unique identification of any LAN card in this entire world, where we are doing uh, networking, we are communicating on different devices. Every LAN card devices have a unique MAC address, and this is the machine manufacturing address. It is assigned when this LAN card or NIC network interface card is actually manufactured. Then we have some more other networking device. One is hub. is a device which actually I'm actually showing you all these devices so that one by one I can explain them and give them a brief summary of all these devices. So we have workstations. Workstations are the systems you are using to transmit information from one source to the other, from one workstation to other workstation, that is one from the source to the destination. Then we have hubs. Hub is a networking device. Through hub, we connect different workstation together in a local area network. Hub has 6 ports, 8 ports, and 12 ports. The multiple ports. Every port we have, as I discussed with you that about LAN card. A LAN card, in LAN card we have RJ45 connected. In the similar way, hub we have the one point of RJ45 connector we insert into the LAN card, and other side of similar type of RJ45 connector we put in the hub different ports of hub. So for example, I have a 8 port hub and I want to send the data from PC number 1 to PC number 8. Hub is a networking device, but it is a very dumb device, because it uh, 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 does flooding and forwarding. What is the meaning of flooding and forwarding? For example, I want to send data from port number 1, that is PC number 1, to PC number 7, port number 7. I have 8 ports hub available with me, and in all 8 ports I have 8 PCs connected. So if I'm going to transfer the data from port number 1 to port number 7, hub hub is a dumb device. It broadcasts that information, that message, for all ports. So in this way, bandwidth is utilized. It does flooding, that in flooding water flows, instead of canals it flows in unspecified paths, which is not for the to flow for the water, which are not defined to flow for the water flow. But in flooding, in a similar way, when you send information from 1 to 7, hub transmit that information instead of one directly from PC number 1, port number 1 to port number 7, 1 to 2, 3, 4, 5, 6, 7, 8. Signal generated for all ports, but when it received in port number 2nd, so when it is going to match it, that device come to know that this message is not for this particular port, so it drops at that particular point. But still we are sending for all ports, so there is no need to send all ports. So we have some other devices later on, we start using some other devices which are intelligent than hub. So basically hub is a device which uh, actually provides you the communication purpose, but it does flooding and forwarding. Messages for the port number 7 only, it sends to port number 2, 3, 4, 5, 6, 7, and 8, all 8 ports. And after reaching all those ports, those messages are drop out because they are not for those specific addresses. And at port number 7, it is going to receive, like at port number 7 the gate will be open for the message, and it is received by the lane card of that particular PC, and that PC number 7 will get that message or information. So it is cheaper, but it is dumb device. It does flooding and forwarding. Then we replace this hub device with some intelligent device we call switch. This is layer 2 device switch. So how there is a difference between hub and switch. Switch is a bit intelligent as compared to hub devices. How? When you are going to consider the same scenario, when you are going to send information from PC number 1 to PC number 7, First time when you have just purchased your brand new switch and you have connected all the devices, all your PCs, all your workstation with that or with the ports of that switch. So only first time your switch will do flooding and forwarding, that it sends from 1, instead of 1 to 7, it sends from 1 to 2, 3, 4, 5, 6, 7, and 8. For example, it is an 8 port switch, although we have 12, 24, and multiple port switches. But for example, it is same scenario, and we have an 8 port switch. Now when first time you transmit the information, it does flooding and forwarding. Why it does flooding and forwarding? So that after on the acknowledgement that where message is accepted and where messages are rejected, in this way, when that it gets the acknowledgement from that particular port, and there is a table, a memory, a table is available inside the switch, in which it maintains the IP address and the MAC address, machine address of all ports, devices connect, all the devices connected on the all available ports. So in a if I will give you an example कि इस तरह से स्विच को समझ आ जाता है कि किस पोर्ट पे कौन सा पीसी कनेक्ट है, उसका क्या नाम है, और and switch try to maintain the addresses of those ports, that in port number 1, PC number 1 having this machine and this IP address is connected. So it maintains its MAC table or IP table. Now when you send any message for a second time from PC number 1 to PC number 7, so switch already know that which port, at which port PC number 7 is connected, so it is going to send only to the port number 7 and not to all any other port. So switch is an intelligent device as compared to hub. It memorizes the addresses, maintain the data address table, and on the basis of that address table, it does not do flooding and forwarding every times. It only sends the information to the destination for which that information is actually belongs to. So then we have some other devices. For example, there are two networks. For example, this is one network, one local area network, and this is other local area network. So if we have many computers to get, we have 500 and 1000 computers, all are in one LAN. So your network speeds or local area communication starts degrading. Your speed starts degrading. So if you want to have a smooth working of all your devices, you can create or you can convert those LANs into two portions. For example, this is one LAN and this is other LAN. If this LAN devices are willing to communicate within the same LAN, so in a very speediest manner, the communication take places, and from the source to the destination, it easily transfer the data without any delay. And if LAN number B is communicate, all the pieces devices communicating of LAN number B within their own network, so it will be very speedy communication. But if A wants to communicate with B, for example, there are two buildings. In one building we have a local area network A, and in the near about adjacent building we have local area network B. So when we increase the devices, instead of our system communication speed starts degrading, we connect it, instead of converting it into a single LAN, we connect two LANs using a bridge. So if you know the word bridge, what mostly bridges does, it connects the one part of the land to the other part of the land when there is a river or a lake or any water flow in between those land parts. So in a similar way, it connects this land into this land, and in which manner it connects, so that its speeds, communication speeds, does not get degraded. So it try to balance the speeds as well, maintain the speeds, communication speed as well, because bridges are very intelligent and expensive devices, so that it can bear the crowded or a huge number of devices at a time without affecting their communication speeds. Then we have router. So this is lane A, this is also, this lane A also belongs to me, and this lane B also belongs to me. ठीक है, this is my own area networks. Local area networks actually belongs to any specific organization or your own, it belongs to you. But when you want to communicate from your network to any network in on the within in the entire universe, so you want a device which we called router. So what is router? Router is a device which connects two different networks. So this is your network at one side of your router, and this, after exiting from the router is on the gateway. When it the ISP, internet service provider network, router one side, at one side of the router you have internet service provider network, and other side your LAN network. So router is a device which connects two different networks. So if you want to connect your network on the internet to the network of Gmail server or any other server, so what happens? So first of all, with the help of this router, your network communication reaches to the your information in internet service provider network, and through your internet service provider network, it travels till the Pakistan Telecommunication Authority gateway, and through the sea, it connects to the sea via Dubai. It connects our network to the first world networks, for example, any Gmail network which is available in somewhere in America, or any Yahoo network. So in this way, a router, any router devices are actually connecting to different networks. LAN, bridges, switches are for the similar local area networks. Then we have firewalls. Firewalls are actually to filter, for the security purpose, to filter out the data coming to your network. We have firewalls like fences we have at borders, so that nobody can enter from border to your area, or to your to in the area which is unauthorized for those people. In a similar way, the bugs and the viruses, we want to filter out all those viruses. For that we have firewalls. Then sometimes we have some more communication devices. For example, if I have my own local area network, or I want to send my information from one source to destination, but destination is far away. And sometimes previously you have seen that we are communicating or accessing the internet with the help of telephone lines. And in telephones line, instead of local area and card, that local area network RJ45 connector, NIC local area network card, that is LAN card or NIC card, we have those. In those times we have modems, that is which we use when we using internet via telephone lines or DSL, the digital subscriber link. So we have modems. So what modems does, your data is traveling through your telephone cables. So what modem is another type of communication device. In modem, that your data, when the message you are willing to send from the source to the destination, it is actually digital. Your computer system is a digital device. So modem, the word modem come from the modulation and demodulation. Modem is a device which converts digital signal into analog signal. Why it converts digital signal into analog signal? So that it can travel the far distance and reach the PTCL gateway, and with the help of PTCL gateway you can connect under the sea through fiber. You can connect through the Dubai, and via Dubai you can connect different internet websites available and servers available in the first world countries which are very far from your source. So in this way you can travel from source to destination. So why it converts, modem converts your data, that is, that I can say, digital data into analog data, because digital data frequency is minimum, or we can say zero. So it cannot travel a very far distance. So what we do, we convert, or we can say modulate, that is, we convert digital data signal into an analog signal so that it can travel, analog signal can travel at far distance, so that it can travel at far distance and reach to the destination. And when it reaches to the destination, we have another modem available with that particular device as well. So every modem, while transmitting the data, the mo and dem, with by by the use of two words, we have given the name to this device, that is modem. That is, while transferring the data from source to the destination, it modulates the signal. Modulates mean we it generates an analog signal, and it writes the digital data on the analog signal. For example, a person wants to move to a very far distance in a desert. So person is a digital signal, and he cannot travel in desert because of the hotness of the desert. So he has to carry a transport mechanism. So for example, if he rides on the camel, so digital data is modulated on a camel, for example, on an analog signal, so that it can reach to the far distance. And at the receiving end, camel is not required at the destination. So camel, uh, he will hang out the camel at outside the house, and that person is going to enter the destination. So in a similar way, when it modulates, it writes modulates the digital data into an analog data, so that it travels at the far distance, and at the receiving point it reconverts, or it demodulates, modulate and demodulate, more than it demodulates the data. It filter out the analog signal and only allow the digital signal to enter into the computer system, and so that you can read the message sent to you from the source. So we have another type of device we call modem. Then we have some more devices, communication devices. Sometimes we have, I can say, repeaters. So for example, you have converted your data into an analog signal, but still this analog signal cannot travel a very far distance. So you have, after every 100 meters in your wire, you used to put a repeater device which takes the signal, or receives a signal which is about to die out before reaching to the destination, and and check the mechanism of the signal generated from the source, and regenerates that signal, regenerate that signal on the basis of the received signal structure, so that it can reach to the destination. So on after every 100-meter distance, or sometimes some more distance, we put some repeater devices so that our signals transmitted data is not going to be die out in between, and it can easily reach to the destination. Sometimes we have two types of devices. One is repeater, one is amplifier. That there is difference between repeater and amplifier. Repeaters receive the signal which is about to die out, and on the basis of the previous signal structure, it regenerates the signal. Amplifiers only amplify the magnitude of the signal so that it can still reach. For example, if you are speaking and your voice is audible to the first two or three rows only, so when you have an amplifier or the speakers which actually amplifies your voice, amplifiers you have in your amplifiers or tape in your home as well, in which you use to listen music. So when you amplify, it actually enhances and increases the size of the amplitude of your analog signal so that it can still reach to the destination and it is easily audible. But what happens, since your signal is traveling from source to destination, so what happens actually, while traveling, the noise is also added, the environmental noise is also added in your signal. So this is the reason when you amplify that particular signal so that it can still reach to the destination, your voice is not going to die out after two seats. You, if you are giving the lecture in the auditorium, so it can easily reach to the last person sitting at the last bench. So when you use amplifiers or speakers louder, so the noise, environmental noise added, it also amplifies. So when you are transmitting or your signal is received at the destination, with there are certain noises also which also amplifies as far as it reaches to the destination. The more the distance you have from the source to the destination, more noises will be added. And when you amplify those signals, so noises added in the signal also amplifies. Sometimes you have seen that when a cable network in cable TV, sometimes your signals, you are not getting a clear images. So after a smaller distance, your cable network uses amplifier so that it actually amplifies your signal, but still you are having some distortion in receiving your TV channels. Some TV channels are very smooth, but in some channels you receive some distortion. So sometimes you call it that, give us any, instead of amplifying signal, give us a direct cable from the source to the destination so that we are not having these noises in our channels. So you have seen all the, you have experiences all these type of things when you are having your cable network or TV net or cable TV uh, communications. So these are the different types of devices we have in different data communication devices. These are different data communication devices. Then I told you that there are communication media. So basically, communication media are basically of two types. Right now, I'm giving you a summary, summarized way. Then I'm going to discuss with you every slide one by one. So what is communication media? Uh, Basically, we have two types of communication media classified into two types: wired or wireless. That is guided or unguided. We also call it guided and unguided. In wire networks, that is from source to destination, we have connected the source and the destination with the help of dedicated links, that is wired. And these wires can be of two types, that is serial communication and parallel communication. Then we have different types, coaxial cable, and we use UTP, that is unshielded twisted pair, STP, shielded twisted pair. Then in simplex communication, we have coaxial cable, which the cable you use in your cable network, cable TV, in which you have only one conductor inside and there is a shield outside. And then in serial communication, you have another type of communication media, which is the fastest available media in the universe, which we call fiber optics, because data is traveling in fiber optics in the form of light, and light is the fastest traveling medium in the universe. Secondly, we have parallel communication. In parallel communication, we have UTP, STP, that is unshielded twisted pair, RJ45. You have seen in your LAN uh, cable net. There is a wire in which you have 8 wires of different colors: RG, orange, white, orange, green, white, blue, blue, white, green, brown, white, brown. These are the 4 sets or combinations of 8 wires which you use in RJ45 connector, and through that RJ45 connector you put it in your router or in your laptops, PCs, so that you can connect your internet or any local area network. So all these are actually wired guided mediums, the dedicated links, but it is parallel types of communication. More we have uh, instead of second type of uh, classification of communication media is wireless, that is unguided. In wireless communication, you use radio frequencies, wire in electromagnetic waves, EMF, electromagnetic waves, and uh, which you are using in your cellular phones, wireless routers, wireless local area networks, and you have satellite communication. So in satellite, again, it is a wireless communication. So all those networks in which you are using less amount of wire, instead of wire you are using air as a medium to, to transfer your data from source to the destination. You can see in cellular communication you have BTS towers through which you are transmitting the data, and that data or the signals is received on your cellular phones. So all the communication you are having, either you are using 4G or 3G services, while you all these services, available services you are having, are wireless communication. So then we have communication network architecture. Basically, we have 2 types of network architecture. One is peer-to-peer, that is PC to PC. You have 3 or 4 or 5 or 2 persons have make their network. Nobody is server and nobody is client over there. The person who is sharing the resources, other is receiving those sources, and if second person is sharing the resources, the first is going to can use as an end user and can avail those resources. So there is no concept of server and client. Peer to peer, that is point to point, PC to PC, or person to person architecture. The other is client server architecture. This type of network you used to see in the organization, where you have a dedicated, a very powerful server in which all the I can say all the services that who can use what are actually uh, uh, allowed on that particular server, and on the basis of that particular server, client can avail the resources which are allowed to them on the server, and they cannot avail the resources which are not allowed to some other users. So for example, there is one printer available for 5 employees or 5 faculty members. So that particular printer or scanner device is actually shared with the help of the server, that these 5 people can use that particular uh, peoples or employees. And sometimes, if for example, if students log in with their own id and he or she want to get a printout, so since the those services are not allowed on the server to the students ids, so they cannot avail that particular facility. So each and everything which you want to do is actually defined or blocked on that particular server. So that is client server architecture. Clients are can only avail the facility which is allowed to them using their that particular dedicated server. So server is actually the resource through which we maintain all our customers and all our clients and our uh, so this is the entire summary of today's topic. Now I am going to specify next video one by one. Slide, I will discuss the slides of data communication device, the communication media we have, and the communication network architectures, and the operating system we are using on different communication network architectures.